Hi everyone, and welcome to this brand new section where we're going to learn how to draw an hyperbola. We're also going to learn what all these parameters inside this general equation mean. Now I'm going to start with this plus p and plus q. Now they are called our asymptotes. Now asymptotes are two straight lines that our hyperbola can never cross. Now they indicate left or right movement. Now let me explain. Let's say this was x plus p like it is here. So we're going to draw our vertical asymptote where we have x minus p. So let's put a value to it. Let's say it was x plus 2. Then we're going to draw the vertical asymptote at x minus 2. Got it? So there's our vertical asymptote. And we're always going to draw it at this p's value with the opposite sign. Because if this was a plus 2, it moved 2 units to the left and not to the right. So please remember that. And then this q tells us how much the parabola moved up or down. And this is our horizontal asymptote that the hyperbola can never cross. So it's basically the borders of the hyperbola. So in other words, if this was a plus 3, we are going to draw the horizontal asymptote at plus 3. So whatever this value is, we're going to draw our horizontal asymptote. Okay, got it. And now, since we know where the asymptotes are, we can look at this a value. Now this a value tells us in which one of these quadrants we have to draw our hyperbola. So if our a value is a positive value, in other words this a is greater than 0, we are going to draw our hyperbola in this quadrant like there and in this quadrant. They are the two positive quadrants. Got it? Okay, excellent. If a is a negative value, in other words this a is a minus or a negative value, it's less than 0, we are going to draw our hyperbola in this quadrant as well as in this quadrant. So basically, we always move these entire sketches on our y and x axis. Now let's have a look at an example. Here we are given fx is equal to 3 over x. Now this is a hyperbola. It can also sometimes be given in the form as 3x to the power of minus 1, and you have to identify that we have to take this base with its negative exponent and put it below the line so it looks like this. Okay, so watch out for this form. It's still an hyperbola. We just rewrite it to this form. Now, is there a plus p? No, you will say, but there is actually, but it's just plus 0. So that means our vertical asymptote is at 0. So our vertical asymptote is on our y-axis and it goes through our x-axis at 0. And we can say that that equation is x is equal to 0. Is there a plus q? No, you will say, but yes, there are. There's a plus 0. So that means our horizontal asymptote will be on the x-axis and goes through our y-axis at 0. So the horizontal asymptote equation is y is equal to 0. And now we basically go and look at this a value, which is a 3. It's positive. So we know our hyperbola will be in this quadrant as well as in that quadrant. And remember, it can never cross the asymptotes. It always moves towards it as close as possible, but it will never ever touch the asymptotes, same as on this side. Okay, so now let's go and draw a proper hyperbola. Now in the next example, we are going to draw this given hyperbola. Now here is our Cartesian plane, and our first step is to quickly go and draw our asymptotes. So here we have x minus 5, so our vertical asymptote will be at plus 5. So we're going to go to positive 5 on our x-axis and we're going to draw our vertical line in, and there is our vertical asymptote. Now what you can do is, at this point of intersection with the x-axis, you can write the coordinates as 5 and 0, or what I always like to do is I just simply like to write the equation of this vertical asymptote as x equal to 5. You remember that from our linear lessons, right? Okay, excellent. Now our next step is to draw in our horizontal asymptote. So this will be at -3. So we go to -3 on our y-axis, which is right over there, and then I can draw in our horizontal asymptote, and there it is. Now again, you can write the coordinates of this point, or what I always like to do is I just simply write the equation of this horizontal line, which is y equal to -3. Okay, so there is our asymptotes done. So the next step is we have just identified our first quadrant, our second quadrant, our third quadrant, and the fourth quadrant in which we can draw our hyperbola. So in which two will it go? Well, here we have a +3, which is a value which is greater than 0. It's a positive value. So we are going to draw it in our first quadrant as well as in our third quadrant. But now what I would like you to see is that when a hyperbola moves left or right and up and down, there will be an x-intercept as well as a y-intercept. So we have to go and calculate it. Now, how do we calculate the y-intercept of any function? Well, we make the x-coordinate a 0. So our y-intercept will then be y is equal to 3 over, and in the place of x we're going to put a 0 minus 5 minus 3. We do this calculation on our calculator and you will see that our y-coordinate is equal to minus 3,6. So this is our y-intercept. So we go to minus 3,6, which I think is right about there. We plot in that point and we write the coordinates as 0 and minus 3,6. Now the next step is to find our x-intercept. So how do we find an x-intercept of any function? Well, we make the y as 0. And remember, fx is the same as y. So how do we find the x-intercept? In the place of y, we're going to put a 0 equals to 3 over x minus 5 minus 3, and we solve for x. So our first step is to take this constant to the other side. It becomes a +3 is equal to, and then this denominator, we're going to put it in brackets to keep it as one thing, and you will see in a minute why. So we have 3 over x minus 5 in brackets. How can I put it in brackets? Well, we basically take out a common 1. Now, since we have only one term on the left side and one term on the right side, and we are dividing here with x minus 5, we can just simply multiply with it on the other side to get rid of it on this side. Now remember, that's why we put it in brackets. Once we multiply with it on that side, this 3 have to be multiplied with both of these values. So let's just write that down first. So we have 3 times x minus 5 in brackets is equal to 3. And then here is a distributive law. So 3 times x is 3x. And 3 times minus 5 is minus 15 equal to 3. Now we simply solve for x normally. We take this constant of minus 15 to the other side. It becomes plus 15. And 3 plus 15 is 18. And 18 divided by this coefficient, which is 3, will give us an x value that is equal to 6. Now I did everything in one go, but I'm sure you are fine with that by now. So we have an x-intercept at a value of 6. So I can go here, we can go plot that point. Since this is 5, this will be 6. So there's our coordinates, and now we can simply connect it. And there is our first part of our hyperbola, and there's the second part of our hyperbola. And that is basically all there is to it. And remember, a hyperbola can never cross the asymptotes, and that's why they will always be in this shape. They move towards the two asymptotes. See you again next time. Bye.